Volume of composite figures. Shapes included would be rectangular prisms, cones, cylinders, maybe a couple others. We'll see. Find the volume of the composite figure. All I'm asking you to do here is find the volume of the top shape, which is the shape of a cone, the bottom shape here, which is the shape of a cylinder, and add the two volumes together. So I'm going to do V sub t here as my total volume. I'm looking for the volume of a cone plus the volume of a cylinder. And I just like to give that my little visual to myself, and there's my volume of a cylinder. So volume of a cone. I'm going to get my formula reference sheet out. Volume of a cone is 1/3 pi r squared h. Volume of a cylinder. Very similar to the cone, but just pi r squared h. I need a radius and a height for my cone. I need a radius and a height of my cylinder. Do not assume they're the same. Actually look into both of them. What's the radius and height of the cone here on top? What's the radius and the height of the cone? Yep.
8 and 6.
The diameter is given as 16, so that means the radius is 8. Excellent. And then the height, making that right angle, is going to be 6. Great. What's the radius and height of the cylinder? What's the radius and the height of the cylinder? Cylinder uses that same diameter, so, yep. Excellent. 4 for the height, and 8 and the same 8 for the radius. Perfect. We have everything we need to plug in, and we're going to let pi equal 3.14. I'm going to write out my formula, show my teacher I know what I'm talking about here. So my total volume is 1/3 times 3.14 times 8 squared times 6. That's the volume of the cone. Plus 3.14 times 8 squared again, and this time times 4. Plug that all into your calculator in one keystroke and get an answer. Plugging all that in, you should get 1205.76. It doesn't tell me what to round to, so I'm just going to leave it as 76. And this is volume, so 76 feet cubed as your units. Alright, so find the volume of this composite figure. You actually just have the shape of a cylinder and the shape of a rectangular prism. So my total volume is going to be that of the volume of a cylinder plus that of the volume of a rectangular prism here. Volume of a cylinder from the last slide, pi r squared times h. Volume of a rectangular prism, length times width times height. What is my radius? What is my height? What is my length? What is my width? What is my height of the rectangular prism? Let's get all that information down first, and then plug in, substitute into my calculator, and call it a day. And again, we're going to use pi as 3.14. What is the radius of this cylinder here? What is the radius of the cylinder? 5? Excellent. What is the height of the cylinder? 9? Excellent. What is the length, width, and height of the rectangular prism?
9, 12, and 12.
Yeah, 12, 12, and 9. That's all the information we need, and the rest is just calculator work. So my total volume, 3.14 times my radius squared times 9 plus 12 times 12 times 9. Plug that into your calculator. You get an answer of 2002.5. Excellent. 2002.5 feet cubed. This one, so in this case, our two shapes are a square pyramid. So the volume of a square pyramid here plus the volume of a rectangular prism. Right? So the volume of the square pyramid is equal to 1/3 length times width times height. And then the volume of the rectangular prism here, a little quick drawing there, is just length times width times height. And I'm going to write down my length, width, and height for each one of them. So the length, width, and height of this square pyramid is just going to be 6 by 6 is the length and width. And the height here coming from the top, coming straight down, making that right angle, that's my 5. And then the length, width, and height of the rectangular prism is going to be 6 by 6. And then the height of this one is only going to be 2. Add them together and you get your total volume. So volume equals 1/3 times 6 times 6 times 5 plus 6 times 6 times 2. And if I do that math there, I get an answer of 162 feet cubed. Is a cylinder with a cutout cylinder on the inside. So a little different from the last two we did, but we added the volumes of the two composites. This one we're actually going to take the volume, so our total volume is going to be the volume of the bigger cylinder. I'll make that a little bigger. And I'm going to subtract the volume of the smaller cylinder that's taken out from this whole piece here. Alright, so then the volumes are both the same, so I have pi r squared h and pi r squared h for both of them, except my radius and my height will be a little different for both of these. So radius and height, the height of both the smaller and the bigger are both 20, but the radius are different. So I'm going to go with the bigger one first. It gives me the diameter, here is 10, so the radius from halfway out is only going to be 5, so the radius of the bigger one is going to be 5, and then the smaller one, here's a 2 on the inside there. See that? All right, so there's my, so the whole diameter is 2, so that means the radius here is actually just 1. All right, and then I got my total volume as, I use 3.14. Erase that. So I got 3.14, so I got pi. Assuming we're using 3.14 for pi, times r squared, times 20 is my height, and I'm going to subtract the next volume, which is 3.14, times 1 squared, times 20. So I got 3.14 times 5 squared, times 20, and then I'm going to subtract 3.14 times 1 squared, or 1, also times 20, and this is going to give me a total volume of 1,507.2 or 2/10 inches cubed, since we're talking about volume. More here, find the volume of this composite figure, round if we need to. So here we have our total volumes can be comprised of, our bottom here is a triangular prism. All right, so we have a triangle here, and we have a prism out of that. So the volume of a triangular prism, let's take that, and let's make that a little neater. And then the last one is going to be a triangular pyramid. Volume of a, again, we have a triangular pyramid on this one. So slightly different formulas, but very similar. So the formula for this one is going to be base times height is the generic formula for the volume here, but this volume, the base is actually the area of the triangle times the height of the prism. I'll make that as a capital H to distinguish the two heights. And then this one's going to be a pyramid, so it's going to be 1/3, and then times the area of the triangle, which is 1/2 base times height, and then times the height of the pyramid. So slightly different there. The base and the height and the capital H is in the height of the prism here. So the base of the triangle here, this is my base here, the 7. The height making the right angle is 6.1, and the height of the prism is 9. And then the base and height of this triangle here is actually the same in base and height. So the base and height of this triangle here is the same base and height of that bottom triangle there. So that's also going to be 7 and 6.1. The difference here, the height of that pyramid here is only going to be 6. So I'm going to take this volume total, and I'm going to do 1/2 times 7 times 6.1 times 9. That'll give me the whole bottom piece here, plus 1/3 times 1/2 times 7 times 6.1, and then times 6 for the overall height of this. And after putting that all together, plug this all in one shot into my calculator, I'll get a answer of 234 points, and since it's rounded to the nearest tenths, it's 0.85, or in this case 0.9 inches cubed.